All right, guys. So I'll throw a question out there. Feel free to raise your hand if you have a guess. But we've learned 3 methods for solving systems of equations. Anybody want to take a guess at one of those? Might be. Go ahead, Denise. Substitution. Go ahead, Lily. Good. And there's one more. Yeah. Graphing. So substitution, elimination, and graphing. Graphing's kind of cool because it gives you an idea about the fact, okay, we've got these 2 lines and where they cross is the answer. But it's a slightly ineffective method because it doesn't give you very precise answers sometimes or difficult answers to see. So we like substitution elimination because they're more precise. They're a little bit more rigorous, though, to figure out, but there they are. Now the question is, why are there 2 different methods? Because technically they would both work. So the answer to that question is in the fact that some systems are set up where you can, it's better just to do elimination, and some are just set up where it's better to do substitution. So let me give you an example. Why do we have 2 methods? Substitution is best used when we have an x equals or y equals. Okay, so let's fill that in on our notes there. Substitution is best used when we have an x equals or a y equals. All right? Together? You got me perplexed, man. All right, so substitution is best used when we have an x equals or a y equals. So just as an example of that, if you have x equals 4y minus 5, and let's say you have 3x plus 2y. I'm going to make up a number here. I guess it doesn't really matter. I'll just make up one. We're not going to actually solve it. But as you guys can see here, we have an x equals. That's a good time to use the substitution method. Okay. And for that, I'm going to say, see your 2.1 notes. Look at your 2.1 notes for that, because that's the first thing that we did was that one. All right. Now, elimination is a good method to go with anytime your x variables and your y variables are lining up. So elimination is best used when the x's, y's, and constants are lined up. So what do I mean by that? So we have x plus 4y equals 8 and negative 3x plus 5y equals 2. So as you guys can see, the x's are lined up, the y's are lined up, and the numbers are lined up. That's a good time to use substitution, and elimination, and that's the method that we learned in 2.2. Now you guys did pretty good with 2.1. I remember that day we did it, and you guys were grasping onto that pretty good. So you're a substitution-friendly group of people here. 2.2 we had a little bit of a hard time on, and that's why we're actually finishing the lesson today, because we didn't finish the lesson. We stopped and kind of kept practicing it. So we'll see if we've developed any adeptness since then. But there it is. So I'm gonna give you guys 2 systems of equations in a second, and your job is to decide which method to use, and then I'm going to encourage you to get out your 2.1 notes, your 2.2, and use that method to solve both. I'll give you a little while to work on them, and then we'll go over them. So let's do that. Somebody still writing? That's for something else. We're going to talk about that guy in a second. But thank you for bringing that to my attention. Are we good? All right. Okay, so I'm going to give you 2 systems, and your job is to, I don't want to write in green. We'll call this example 2. Determine, I know there's an example 2 in your paper already, but I'm going to switch things up a little bit. Determine which method to use. And then using that method, solve the system. Okay. So I'm going to give you two problems. Here's A. Sorry, I'm just making these problems up in my head, and I want to make sure they work out nice and don't have fractions in them. Okay. All right, so I'm going to give you guys a little bit of time. So you need to decide which method to use, and then you need to probably get out your 2.1 notes if it's substitution, and look at that to remind you. And then you can look at last class's notes to do the elimination if you see that one, okay? Yeah? I thought I saw a hand, no? Okay, so I'm going to give you guys a little while, and then we'll go over them. So this one is the elimination method because the x's and the y's are lining up. And if you use your 2.2 notes and work that through, you should be getting 2 for x and negative 1 for y. The substitution method is this one because we have a y equals. And on this one, we should have been getting a 3 for x and a 0 for y. So far today we've looked at how do you know when to use elimination, how do you know when to use substitution. Now we're going to move on to a new situation here. So we're going to solve this one together. I'm just going to call on you and you can tell me what you believe the next step is as we're solving it. I'm doing this problem though because something interesting is going to happen along the way as we're solving it, and that's the next topic I wanted to get to talk to you guys about. So my first question, I'll wait 3 seconds and then I'll call on somebody, but my first question is, what method would I use, substitution or elimination? What do you think, Shamani? Substitution or elimination? Elimination? No. Now here, let me tell you why. Because in elimination, the x's and the y's line up, and you see how my x's and y's aren't lined up here, like these equations aren't matching, right? Now the clue that it is substitution, though, is the fact that I have a y equals. Okay. So Vidal, after I find the y equals, what's the next step with substitution? You're warm, and you might be thinking it right. It's not being said right, but I think you might be right. I still give you credit for that, but does someone want to give me a little bit of a clearer explanation there?
Plug in y. Plug in the first equation into the second equation.
Okay, so we're going to plug the first equation into the second equation. So on the paper, the steps that I gave, that's the big picture. On the steps that I gave you in your 2.1 notes was after you find the y equals or x equals, you circle what it equals, and you plug it into the other equation. Now, am I going to put it in for x or y, you guys?
Y.
Because I want to know.
Why?
Because I want to know.
Oh, God.
All right, sorry. Little stupid joke there. Thank you. All right. Get it? Why?
Yeah.
All right, so we're going to plug it in for y. 4x minus 2 equals 10. And I'm replacing the y with 2x minus 3. All right. Michelle, what's the next step? Yeah, let's do that. Let's do some distribution. So we're going to distribute. Now we're multiplying a negative 2 there, so that's going to be negative 4x plus 6 equals 10. All right. What's the next step? What would you do to solve this next? So think about it for a second. I'll give you 3 seconds, and then I'll call on you. What is the next step? What do you think about Ms. Maya? What would you do next to solve this? Take a guess. Any guess. Okay. We are going to do something like adding. It's like just combining. And so what we want to do is we want to combine the like terms. So the like terms are the two that have the same variable on them. So like these two we can combine. Now what's interesting about 4x minus 4x, what happens there? They cancel out. That's the weird thing that I wanted to point out to you on this problem. This is weird. Okay? My letters went away. I'm trying to solve for x and y, and in the process I get this. There's no how can I solve for x if it disappears? That's
No solution.
there you go. That's a no solution problem. Now let me explain why though. So when the x's and y's disappear, it could be two different things. It could be no solution, or it could be something we call infinite solutions. Now, the reason why we know that this is no solution, so let's go ahead and write that, no solution. The reason that we know this is no solution is because of this. Does 6 equal 10?
No.
There you go. So, in other words, in these two equations, x and y don't matter. They just kind of cancel out. It just seems like, and therefore, since they don't matter, no matter what you pick for x and y, you're never going to get something that's true. It's always going to be false. And therefore, there's just no solution. Yeah? Okay. So there's our answer. There is no x, there is no y to solve for. Bonus question, I'll give you 2 points if you can answer this. If I were to solve this by graphing, what would I see? Nice job, Edwin. Very good. Remember, back when we did graphing, systems of equations are the solutions where they cross. So if there was no solution, they were parallel. If you were to graph those two lines, they would be parallel. That's why there's no solution. Good memory. Yeah.
If like it was 10 equals 10 and the equation is true, would it be infinite?
Yes. Yeah. Very good. Yeah. So let's go ahead and take a look at that then. That's our next slide. So here it is. Sometimes when solving systems, both variables end up canceling out. So let's ask David. David, I didn't give you time to think about it, so I'm sorry. I'm going to make you think on your feet here a little bit. But what method would you use here, elimination or substitution? All right, 50-50, but that wasn't it. So it's elimination, and here's why. Because the x's and the y's line up. You still get credit, though, for your effort. So the x's and y's line up. Now, I picked these ones because they're easy to solve. I don't have to do a whole lot of work on these because do you guys see how they're already opposites?
Yeah.
So I don't have to multiply it. So this is kind of like a little, I made it easy so we could skip a lot of steps. But I'm just going to jump right ahead to step 4, and I'm going to combine these. Let's add these together. What's x minus x? 0. So they cancel. What's y minus y?
0.
So all I'm left with on this side is 0. And on this side I have 0 also. 2 and minus 2 is 0. Is that true? Does 0 equal 0?
Yes.
What this means is that these two equations are actually the same exact line. And what that means is no matter what you pick for x and y, they will always have the same solution. In other words, you don't have two lines really. You have just one line. They just look different. And they have every point in common. So this is what we call infinite solutions. So when this is true, when this is a true statement, you have infinite solutions. But when it's not a true statement, it's no solution. And that's what this one is over here. So let's add these up. x and negative x is 0, y and negative y is 0. But what's 2 and 4? And is that a true statement there?
No.
That's false. And since that's false, we say no solution. Okay? So that's a weird thing that can happen with systems of equations. You can get no solution or infinite solutions. Those are things that happen when the x's and the y's cancel out. If you end up with a true statement, it's infinite. If you end up with a false statement, it's no solution. So I'm going to let you guys do a problem now. And I want you to solve it. And it's going to be one of these. You're going to see that your x's and y's just kind of disappear. And your job is going to be to decide, is it an infinite or a no solution? So, and that'll be our last thing that we're going to do today. So let's see what you guys get here. So take some time and knock that one out.